Hello, welcome to physics. As we begin our new exploration of physics, we need to first understand that physics is all about energy as it relates to matter. In other words, what we are going to be looking at motion and what causes motion and how to describe motion. So beginning this conversation, we need to first understand what motion is and have a definition that we can use to move forward. Motion can be defined as when an object changes position over time relative to a frame of reference or a reference point. A couple of key things here that I want to highlight is this use of the word position. So that is a term that's going to keep coming back up over and over again as we talk about motion and looking at an object's position. And we also need to make particular interest in the use of time, because time is going to come into play as well. Now, this frame of reference or reference point, there's a couple of different ways of looking at this, and we'll examine those in the next couple of slides. Take, for instance, Mickey here. Any kind of cartoon animation makes use of position and frame of reference or reference point. For instance, if we were watching this cartoon of Mickey as he slam dunks the ball, the animators use the clouds in the background and the hoop to show that Mickey's actually moving. But when you watch a cartoon, the character is usually positioned relatively close to the center of the frame, and their position doesn't move with respect to the frame, but with respect to the background or other reference points. Here, the hoop, Mickey is shown to be in motion because he's changing his position with respect to the hoop. I'm providing two examples here of men running. The one on the left is running on a treadmill, and using our definition of motion and what motion is, he is not moving because his position relative to the treadmill is not changing. He's directly over the center of the treadmill, and even though his legs are moving, his position with respect to the treadmill does not change. However, as we look at the guy on the right, if we were to watch a clip of him moving, we would know that he is in motion because we have the mountains in the background and the grass in the foreground, and we can measure his change in position relative to those reference points. So far, the examples that we've looked at have made use of our frame of reference being as a bystander as we watch something else move. But our frame of reference can change. And in this illustration here, this cartoon, we have a lady in red on a train and a person in yellow standing on the ground. And they have different frames of references. And we're to assume that the train is moving to the left as we view it. And the person on the ground is standing there watching the train move away, and so there is motion relative to each other. So let's examine these frames of reference. The person on the ground would have a fixed frame of reference. As they stand on the ground, the train is moving relative to their fixed position. Whereas the person on the train is in a moving frame of reference, and they're moving with the train, and it looks like the person on the ground is moving relative to their frame of reference. I know this can be a little bit tricky, so we're going to get a little more in-depth look at this by looking at the classic film frame of reference using these two gentlemen here. These two gentlemen are professors, and they do a great job of illustrating what the difference is between a fixed earth frame of reference and a moving frame of reference.